Hey everybody, we are gonna switch back to one of our first topics from the year, 7th grade style now. So we're gonna review ratios and rates a little bit today. We're gonna throw in some fractions, which is a big part of the difference between ratios and rates in 6th grade, which we did probably in September, and ratios and rates in 7th grade. So make this the title of your next page. You don't have to write it in a 1980s video game font like for some reason I have here. But you can, and then once you have your title, unpause, and we'll get going. So, when we talked about ratios, and especially like unit rate problems where we use the ratio strategies, we had 4 strategies that were helpful in these cases: proportion, double number line, tape diagram, and coordinate plane. And I'll try to go quickly enough that I can kind of review all 4 of those with you on some examples as we go. Most of you preferred certain ones over others, and we also talked about how like certain ones were good in certain kinds of problems and not necessarily in others. So it's not necessarily super important that you be amazing at all 4, but I want you to know how they all work. So they're all tools in your toolbox. So let's do a example that's going to have a little bit of 7th grade part of it, and we'll review the strategies here. So if a cyclist rides 6.5 miles in 1/3 of an hour, what was her speed in miles per hour? So there you go. That's rate language. If you haven't remembered, miles per hour. So that's like miles in 1 hour. And this one's probably not too bad to just figure out in your head. You can probably do. But I do want to use this one as a good chance to review the ratio and rate strategies with you since it's not super complicated. So the big difference from 6th to 7th is that we're going to have fractions in our unit rate and ratio problems, which we didn't have too many of in 6th grade. So let's do this. I'm going to copy this and bring it to the next page what I have set up for them all. So I'll put the question kind of up here, and maybe I'll do that. I'll do tape diagram last. That one was one you guys didn't typically love, though I kind of do. And then I'll delete the question by then because we'll be used to it. Okay, so let's review. So the way I would do this with a double number line strategy, I love this one if I'm going to be going up, in just like repetitions of the of one of the numbers. I don't like it if I have to kind of go backwards and divide. It gets a little confusing, but this is a good case for it here. Because the way I would set it up is I would set up a number line for miles, and I would set up a number line for hours. Boy, that is slow. Ugh, it's bad even for me. Can't get this thing to write. Hours. And I would write the one I know, so 6.5 miles in 1/3 of an hour. And I want to know how many miles in 1 hour, miles per hour. And as you can see, we're just going to go up in repetitions of what we know. So if I can do, or she can do 6.5 miles in 1/3 of an hour. If we did that again, then she would have done 13 miles. That's 2 sets of 6.5 in 2/3 of an hour. And one more is going to get us to 1 whole hour. So one more rep, that would be 6 more, would be 19 and a half. So that's how my double number line gets me to 19.5 miles per hour. Great one for a double number line. It's great when you go this way. Double number lines are not as great. They can be, depending on what you think of them and how you reason with them. If you have to go backwards, they can be a little tougher. Okay, I'll come back to tape diagram. Proportion strategy was the one you all tended to like the most. I would set it up and say, okay, I'm going to make all my proportions be miles per hour. And I know that I have one part of my proportion is 6.5 miles in 1/3 of an hour. This is weird looking, but it kind of is going to still work for us in the proportion strategy. It's weird to have a fraction in a fraction. And when that's the case, we're going to call that a complex fraction. It is not okay as like a final answer. Like you can't write this down as a number. But it is okay to use in the proportion strategy. It's still helpful because saying, okay, 6.5 miles in a third of an hour, that's how many miles in 1 hour. And the reason it's still helpful is this is still a very easy multiplication to make. I know that 1/3 times 3 is going to give me a whole. And so really, it's even though it's a weird looking thing, it's a very useful tool. So if I'm going to multiply my denominator by 3, then I'm going to multiply my numerator by 3. And 6.5 times 3. 6 times 3 is 18. A half times 3 is 1.5. So I get 18 plus 1.5 is 19.5 miles per hour. Great strategy. Super, very clear when using that strategy, and works great. Coordinate plane. We did too, so we would make like an x-axis and a y-axis. So I'm going to make an axis here. And maybe do my miles here. And then I'm going to have an axis here. And do my hours here. And I might slide that up a little so it's easier to see. There we go. And here we go. So I'm going to go, remember down here I've got to go in even increments. So I guess the logical thing to go in would be 1/3 of an hour. 2/3, and then 1, and I could keep going 1 1/3, and so on. I'll just stop at 1 because that's as far as I need to go. And my miles, maybe I'll go in 5s, 5, 10. No, let me go less. That's going to get too smushed. Because I'm only going to 19.5. I already know the answer. Why don't I go in like 2s, 2, 4. Remember, I labeled the line segments, not the spaces when I use the plane. 6, 8, 10, 12, 14, 16, 18, 20, 22. And here we go. So I know in 1/3 of an hour, she goes 6.5 miles. So 1/3, I'm going to go up to 6. Halfway would be 7. So I need 6.5. That's about right there. That would mean 2/3 was to 13. So 2/3, 12, 13. And a whole hour, 1, up to 19.5 right there. And if you do this just right, you should be able to, and it's hard to do that, especially if you don't have graph paper in your notebook here at home, you should end up with a line that goes through 0, 0, and through here. And so if I had more space, I could keep and say, all right, well, how far does she go in 1 1/3 hours? And it would be up here somewhere. And I can also tell how far does she go in 0 hours. She goes 0 miles, which makes sense. All right. And so the last one's the tape diagram. I'm going to delete the question since I think we know it. This tended to be your least favorite, but it's always good to review just so you know how it works. So I'm thinking about parts and wholes here. And what the thing where I know the part and the whole is I know 1/3 of an hour and I want to know a whole hour. So when I make my tape, I'm going to kind of think of it in 3 parts and say, okay, this whole thing is an hour. And each part is like 1/3 of an hour. Right? So I'm thinking of this whole thing as being an hour. And my parts as being 1/3 of an hour. And if you can do 6.5 miles in 1/3 of an hour, it's easy to then fill in the tape for the tape diagram. And it just gives you a nice visual picture of like, okay, this is my hour of biking, 1/3 of it 6.5, 1/3 of it 6.5, 1/3 of it 6.5, which makes 19.5. So I like it. Pretty good strategy. All right, open your notebook. Let's do one together. And I may have to pause and do a few things to speed this up, running out of time. So here's your question. If Molly runs 2/3 of a mile in 6 minutes, how long should it take her to run a full mile at the same speed? So go ahead and write the question down, and when you are ready, you can work it out on your own, or you can work it out with me. I'm going to copy it, and you'll also need a space to use all these strategies. I'm going to put the question there, but I'll undo that when the time comes. So unpause when you are ready to go. All right. So this is not a great, well, it's going to be an okay one for a double number line. Let's write down what we got. So we got miles, and we got minutes, and I need a number line for each. And the one I know is, we know obviously she runs 0 miles in 0 minutes. That's always a nice one to put on your double number line. I know she runs 2/3 of a mile in 6 minutes. And I want to know how many how many minutes it is to run 1 mile. 1 mile, how many minutes, right? So what might help here, this is, if I just do another rep here of 2/3 and 6, I'm going to go past it. And I'm going to go out to 1 1/3 in twice as long, which doesn't help me. But it kind of does, because you can look and say, okay, well, it's halfway in between. 1's halfway in between this and this. So 9's halfway in between this and this, and that's going to be the answer. That's one way to do it. Another way is you could say, okay, well, I'm going to go back and fill in this one, and that might help me. Say, okay, if it's 2/3 is 6, then 1/3 is halfway back, and that's 3. Now I'd get 1/3, 2/3, 1, 3, 6, 9. Same thing I got before. So either way, the number line is kind of a nice tool on this one, and does help you kind of figure out how to do that. So it looks like she can run 1 mile in 9 minutes. All right. Let's go to proportion. I'm going to set up my proportions in miles to minutes. So she can do 2/3 of a mile in 6 minutes. That's a complex fraction, if you want to write that term down. Complex fraction. Not a good number, but a good tool for helping solve ratios. And I want to know 1 mile is going to take her how many minutes. So I would have to see, what am I multiplying 2/3 by to get 1? You guys are good at doing that on your calculator. I happen to know I'm multiplying, it's 1 1/2 of these, because a half's another third. So I'm multiplying this by 1 1/2 to get to 1 minute. And so I'm also going to multiply this by 1 1/2. And it's going to give me 9 minutes. Half of 6 is 3. And so 6 times 1 is 6. 6 times a half is 3. That gives me the 9. So she can do 1 mile in 9 minutes. Okay. I may run out of time after this one, so I may leave you the coordinate plane to do on your own. That may be hard to do without graph paper. But do your best. So I'm going to do the tape diagram one, because that usually confounds us a little more. So again, I'm thinking of which one do I know the part and the whole. And in this one, I feel like that is the miles, right? I want to know about a whole mile, but I only know about 2/3 of the mile. I know 2/3 of the mile, I'm going to do that, takes her 6 minutes. And I want to know how long the whole mile takes. Well, if I look at it that way and say 2/3 of it takes her 6 minutes, that means each of those thirds is 3, which means the other third is 3 as well. And so the whole thing takes 9 minutes. And you know how it was with tape diagrams. When you watch me do one, they make perfect sense. But then when you have to do one, they're kind of hard, because it's like, oh, do I do minutes in here and time out there? Or miles out there? Do I do miles in here, time out there? What's the whole, what's the part? They're easy when you see them. They make a lot of sense, but they can be hard to do. So I'm out of time for the coordinate plane. So I want you to use these figures here in their double number line and make yourself a coordinate plane representation out of them too, and then you'll have all 3. Hopefully this made lots of sense and brought back a lot of review information about ratios and rates from way back in September when you were wee 6th graders, and kind of get you back up to speed and get you started on doing them with fractions as well. See you tomorrow.